So we're ready to begin the fifth lecture. I'm glad to be back. Thank you for entertaining my colleague Haynes Miller. So today we're going to continue where he started. Namely, what he talked about was the chain rule, which is probably the most powerful technique for extending the kinds of functions that you can differentiate. Now we're going to use the chain rule in some rather clever algebraic ways today. So the topic for today is what's known as implicit differentiation. So implicit differentiation is a technique that allows you to differentiate a lot of functions you didn't even know how to find before. And it's a technique, let's wait for a few people to sit down here. Physics, huh? Okay. Well, more physics. We'll take a break. You can get those after class. All right. So we're talking about implicit differentiation, and I'm going to illustrate it by several examples. So this is one of the most important and basic formulas that we've already learned part way, namely the derivative of x to a power is a times x to the a minus 1. Now what we've done so far, what we've got so far is the exponents 0, plus or minus 1, plus or minus 2, etc. You did the positive integer powers in the first lecture, and then yesterday Professor Miller told you about the negative powers. So what we're going to do right now, today, is we're going to consider the exponents which are rational numbers, ratios of integers. So a is m over n, m and n are integers. All right, so that's our goal for right now, and we're going to use this method of implicit differentiation. In particular, it's important to realize that this covers the case m equals 1, and those are the nth roots. So when we take the 1 over n power, we're going to cover that right now, along with many other examples.